Now let's review this caller runtime environment. Okay, what I mean by that. So caller's runtime environment consists of all the registers and program counter pointing to the next instruction in the caller. Okay, so that means you are essentially you are actually going through this program instruction from the beginning one by one, and you know the next instruction PC program counter's value is the address of the next instruction. So that needs to be preserved across your function call and all other registers. To preserve that means a caller's runtime environment essentially means save all the register value and the program counter at the beginning and restore all the register value and program counter before return. Okay, that's essentially that means. But it's too much, right? It's all 32 registers. That means we somehow need to save them and restore back. So there it comes your software convention. It is sufficient to save following register, right? A0 to A3, the arguments, if overridden in the function. Why it will be overridden by the function? In general terms, if it calls another function from it, right? If it calls another function, that you need to pass those arguments through this register A0 to A3, and you are overriding essentially whoever caller's environment with that. So you need to reserve that. But again, it is unconditional. If you are only overriding that those three registers within your function implementation, only then you are going to save them. Let's say you are using like all four arguments. Like you need all four arguments that caller need to pass to your function A0 to A3, and then from your function you are calling another function which takes maybe two arguments A0 and A1. In that case, you need to save only A0, A1. You don't need to save all four. Then you need to save S0 to S7, these 8 registers. Okay. S register, remember when we discussed the register like utilization of the registers and registers as a memory storage, etc. Those lecture we tried to establish certain usage pattern with some specific set of registers, right? So we tell the T is temporary register, S is save register, A is argument. Now this convention is mostly used here at the function implementation and calling context. Okay, those things. So S register by our convention are all saved across the function call. Means when caller calls your function, okay, and you return it back from your implementation, you should not alter any of this register S0 to S7. What it signifies, that means in your function implementation, if you are using any of these register between S0 to S7, you need to save its value first, then use, then before return you restore its value. Okay, and we need to save stack pointer, frame pointer, and array return address, those register. Why you need to save that array? Because if you call another function, you are going to you're using jump and link from there. Jump and link will go and override array. So you don't, then in that case, you just lost the information that where to where you go and return at the caller space. Okay. So this becomes like only a few set of the registers. So any code should not use GP, K0, K1 and AT. So we don't need to bother about them. 0 is a constant. We don't need to bother about them. V0, V1 is used for returning the result. So of course we'll go and can change them. And T0 to T9, these are not saved as a convention. So we don't need to bother about them, right? So we only need to bother about A0 to A3 and A0 to A7 if we are overriding them, and stack pointer, frame pointer, and $array. You may argue that if I am not calling another function from my function, why should I actually go and save my array? Because I know I'm not going to change the array. So shouldn't I just make the assumption that it will go back into its place, right? Think this way, right? You are implementing a function, and at the point of implementation, when you are implementing it, you think that you are not going to call any other function, right? Because you know, like, okay, that's how one way you are going to implement the function. So once you are done, let's say you go and change your mind and say, hey, let me refactor my code and let me do another piece of function which will be called from this function. Then at that point, you are going to need to go and save the array, right? The point is that can give rise to a problem of, you forget to do it, right? So it's a good practice. It's a suggestion always to keep and store and copy of the array before you mess up anything, right? So theoretically, if you are implementing function from scratch, you're not going to call anything, you need not to save the array, but this is a good practice and we'll follow this convention in this class. Because if at any point of time you think you need to refactor, there is a high chance that you are going to forget to store this array and then certainly go into deep trouble of why function is not behaving correctly. All right. So as a good practice in this class, we'll always store array. Okay. A0 to A3, again, let me remind you, in your textbook, that convention says it need not preserve A0 to A3 across function call, but in this class we are assuming this. Your programs, your project assignment, that code assumes that part, so don't mess up with that assumption. So in this class, we assume A0 to A3 is unchanged in the caller runtime environment. S0 to S7 also unchanged. Stack pointer, frame pointer, and array, they are also unchanged.